Hi students, welcome to homework number 7, question 2. This question is asking which of the following solutions of strong electrolytes contain the largest number of ions. And because we're allowing unlimited submissions, you could just click one of the 3 options and submit to see if it's correct. If it's not correct, you could just move on to the next one and click and see if that one is correct and so on. But let's actually look and solve this question properly. Because we're trying to calculate or choose the selection that has the largest number of ions, we'll need to find the moles. In theory, we could find the moles of all the ions and then multiply by Avogadro's number, but in comparing them, it won't really matter if we multiply each of them by Avogadro's number. They'll stay in the same order. The largest will stay the largest if we multiply it by Avogadro's number, and the smallest will stay the smallest if we multiply it by our Avogadro's number. So really, we just need to find the moles. We'll be using the definition of molarity to find the moles. Molarity, of course, is equal to the moles of solute divided by the volume of the solution measured in liters. And we're going to rearrange this so that we're solving it for moles of solute. So the moles of solute is equal to the molarity of the solution times the volume of the solution measured in liters. So the first solution has a molarity of 0.3. Let's call that one A. And the volume is 450 milliliters. If we change that to liters, that will be 0.450 liters. So 0.3 times 0.45 is equal to 0.135. So that's 0.135 moles of the solute NaOH. NaOH breaks apart into 2 ions when placed into water, the Na plus ion and the OH minus or hydroxide ion. So the total moles of ions would be 0.135 moles times 2. So that would be 0.270 moles of ions. And we could multiply that by Avogadro's number to see how many ions that is. But there's no real reason to multiply all 3 of them by Avogadro's number. I can just find the moles of ions and leave it at that. Choose the largest one. That would also be the largest number of ions. For the second selection, the molarity is 0.150 and the volume is 50 milliliters. 50 milliliters is 0.05 liters. So 0.15 times 0.05 is 0.0075. That's the moles of solute, which is barium chloride. Now, barium chloride breaks apart into 3 ions when placed into the solvent, into the water. 1 barium ion and 2 chloride ions. So, the total moles of barium chloride, 0.0075 times 3, will give us the moles of the ions. and that's equal to 0.0225. And again, we could multiply that by Avogadro's number, but there's no real reason to, because the largest number of moles of ions will also be the largest number of ions. In part C, we have a molarity of 0.35 and a volume of 40 milliliters. Moles equals molarity times volume again. The molarity is 0.35. The volume is 40 milliliters, so 0.04 liters. 0.35 times 0.04 is equal to 0.014. That's the moles of the solute. In this case, the solute is Na3PO4. Now this solute is going to break apart into 4 pieces. 3 sodium ions, and 1 phosphate ion. So to find the total moles of ions, I would multiply 0.014 moles times 4 ions. And that's equal to 0.056. And now I just need to choose the largest one. So 0.056 moles of ions, 0.0225 moles of ions, 0.270 moles of ions. So the first solution has the largest number of moles of ions. So even though these other 2 solutes break apart into more pieces, the barium chloride breaks apart into 3 pieces and the sodium phosphate breaks apart into 4 pieces, the sheer volume of this first solution means that it's going to have the most ions floating around in it. So the answer to that one is A. Okay, thanks.